Okay, so we're going to solve this problem. So we have to use Cauchy and Euler's rule as well as variation of parameters, as this thing does not equal 0. So we're going to use so there's going to be yc and yp. So let's first find yc. So yc, we can't just factor this because of the x's, and we can't just factor them out easily. So what we're going to do is set y to be equal to x to the power of m. So let's set x squared y double prime minus 3xy prime plus 3y. Set y prime to be m x m to the power of minus 1 m minus 1, and the y double prime will be the following. Okay, so now we just plug in the y's into here, and this is all equal to 0. Now recall, we could rewrite these x's like the following, and we see this cancels out, and this cancels out. So now we have y, so m times m minus 1 times x of m minus 3m times x to the power of m plus 3x to the power of m equals 0. These all x's cancel each other out. So now we have m times m minus 1 minus 3m plus 3. So this is just m squared minus m minus 3m plus 3. So m here. Alright, so m1 is equal to 1 and m2 is equal to 3. So yc will be c1 times x m1 plus c2 times x m2. Okay, so this will be 1, this will be 2. So this one will be 3. Okay, this is because the roots are different. So the formula for yc when we use Cauchy and Euler's rule is going to be this. If we were not using that rule, then we would just do e to the power of m1 times x plus e to the power of m2 times x, and then we have the constants here. But since we're using since we had y equals x to the power of m, we have to do it like this way. Okay, so now we have yc. We have to find y1 and y2. So y1 will just be x, y2 will be x cubed. Now let's find our w values. So w is going to be a matrix. So we have y1 here, y2 here, y1 prime, and y2 prime. So, and then we have to find the determinant. So that will be x cubed, 1, 3x squared. So that's 3x cubed minus x cubed equals 2x cubed. So that's w found. w1, okay, so the top left side will always be 0, and the right side, so what we're going to do, so a lot of people are going to just take this to be the right side. But the problem is the y double prime has to be being times by 1 in order for us to do that. So what we're just going to do is have this equal to the following. Divide everything by x squared. So this just becomes x. This becomes x squared. And this becomes 2x squared times e of x. So we're going to put that here. And then the right side is just this part. And let's find the determinant of this. So it'll be minus 2x to the power of 5 e of x. Now w2, it's the left side, which is this, times the right side, which is this. Alright. So the determinant of this will be 2x cubed e of x. So now let's find u1, which will be the integral of w1 over w d of x is equal to the integral of minus 2x5 e of x all over 2x cubed. This cancels out. We can take the negative out here. And this gives us minus the integral of x squared e of x. Now we can use the DI method to solve this integration by parts. So we're going to differentiate one all the way up to 0 and integrate the other one. Then we add this plus minus plus minus. So this is going to be negative because of this negative sign in front of the integral. Then we include this part, x squared times e of x. Then this part, but with the negative here. And then finally the last part. And then we, FOIL in the negative. Alright, so that's your u1. Now your u2 will be the integral of w2 over w. So it's 2x cubed e of x all over 2x cubed. So this cancels out. So it's just the integral of e of x. So it's just e of x. And we're taking the constant to be 0. So u2 will be e of x. So yp will be u1 times y1 plus u2 times y2. So recall y1 was just x and y2 was x cubed, and we just plug in u to get our yp. Alright, and that's your yp. To get your y, you just add yp with your yc, and that should be it.